Hello there. I just wanted to give kind of a small bonus lecture on the idea of where electrons are in terms of their orbitals. So here we're looking at a notebook page, and what I want to show is something um, kind of, well, I guess sort of like this. So assume that we have some orbital that is like this. Ah, sorry, I don't have my pen with me or my awesome drawing tool, so it's gonna be a little different. But imagine you had some carbon oxygen double bond here, and the oxygen has two lone pairs like that. The question is, what orbitals are those double bond or are those lone pairs in, right? So to think about this, we have to look at the hybridization of both the atom and then where the electrons might reside. So the hybridization of an oxygen is, if you can remember, sp2 because the lone pairs are in um, the orbitals, kind of like this, and you have 120 degrees between the bonds and the lone pairs. So here, what you need to focus on is finding, as we said, those the placement of where the lone pair of electrons is. So here it's sp2. We can just draw that in. That's sp2. So for instance, if we had a carbon, sorry, let's try to draw that better. If we had a carbon and it had a lone pair of electrons here, and they were in this orbital, what would the hybridization be of that pair of electrons? Well, hopefully you've seen that the hybridization there should be sp3 because a carbon with three bonds and a lone pair is tetrahedral, and the carbon itself is sp3. But the question remains, what about something where you don't necessarily have um, perhaps sp3 or sp2 characteristics, even when it looks like maybe it should? So here, what we have is what's called pyridine. It's a molecule that has that has a nitrogen and a ring system here. And the ring, actually, if you were to look at it, has, let's see if I can draw it. There we are. And we'll put the nitrogen here. Come on. There we are. The nitrogen's kind of in that vertex. Let's draw that a little better. Let's start here with this nitrogen. There we are. And try and draw it kind of on the side. There we go. We would see that each of the orbitals for those double bonds, because they're pi bonds, remember? There we are like this, and the nitrogen also contributes one. But that lone pair is actually out here not contributing to the pi system. So because it doesn't contribute to the pi system, we don't call it, or we don't say that it is in one of the p orbitals. Instead, what we say is that it is in an sp2 orbital, which is a pretty important distinction for the pyridine system. There are some systems where this is the case, and pyridine is one of them. Now, let's move this down a little bit. So another example, basically you're looking for anything where the lone pair of electrons might be different than the hybridization. So if you have a look at maybe just a simple carbon-carbon double bond, let's draw this not in bond line structure. We'll have two hydrogens here coming off. Okay. Remember that two of these bonding hydrogens are in sp2 orbitals, and two of the electrons, and two of the electrons are in the p orbitals. Okay, so you could ask yourself, how many electrons in a p orbital does this have? And that would be 2, because each one of these carbons has an electron there. But then it also has 6 electrons, or sorry, 1, 2, 3, 4, 5, 10 electrons in sp3 orbitals. So there is a little bit of a difference there. Okay, now, I think that's enough of a little primer. You'll notice that there's a question kind of like this in your homework. So hopefully this helps you out a little bit in understanding what that's asking for. And please ask questions in the recorded session or in the office hours if you still have more questions. Thanks.